Okay, hello. We're going to be learning about solving equations. And I think the big step today is going to be, do we know how to do this if there's a variable on each side of the problem? Okay, so I think the big thing that we're going to be talking about is if we're trying to solve for x, but there's two of them, how do you make x be alone if there's more than one? Now, I think when we talked about yesterday's assignment, there were times that um, we had more than one step, but I think today's feature is yes, there's gonna be more than one step, but here is the step that we're gonna the order that we're gonna work. We're gonna do distributive if we need to. Then we're gonna combine like terms on each side. Okay, so you're gonna tidy up the left side, tidy up the right side by combining like terms. So distribute and combine like terms. That's gonna be our very first step here. Okay, combine like terms. So we're gonna put these together. And then we're gonna use the property of equality to get the variable terms on one side. How we're going to do that, we're going to use adding and subtracting. Okay. Then we're going to put the constant terms on the other side using adding and subtracting. It's how you move a term from one side of the equation to the other is you add or subtract the opposite. Okay. And then the last step we're going to do is to isolate the variable. And we are going to isolate the variable, and how you do that is normally with multiplication or division. Okay, so that's how you normally do this. So add and subtract is what we're going to do to get all the same kinds of terms on each side. So the letter terms on one side, the number terms on the other, using adding or subtraction. And then we're going to use multiplication and division to get all, to isolate the variable term. And so I think on this one, if we look at this, we'll notice if we draw the vertical line, you notice there's x's on both sides. So I would always move the x's to be on the same side. And so if I want to move the 5x to go to the left side, notice the sign in front of the 5x is a positive 5x. So we're going to be subtracting 5x from both sides. As long as you do it on each side of that the equal sign, you're fine. And then you get 2x minus 4 is equal to, bring down the 16. Now we want to put the number terms on the other side, the constant terms. So we're going to move the negative 4 by adding 4 to both sides. Now notice if you draw the vertical line here out for the equation, you'll see that you're adding 4 once to each side. You can't do it the same 2 times to the same side because then it kind of gets lopsided. You end up with 2x is equal to 20. And your last step is to solve for the variable itself. So to get rid of the coefficient of the variable, we're going to divide both sides by 2 and x equals 10. On the next one, you'll notice that, again, there's variables on each side. So you got to pick a side. Where do you want to put the letter terms? And I want to move the x term to the other side. So I'm going to minus x from both sides. I should get a pen. Here we go. So minus x from both sides, because in front of the x, there's no sign. So that means it's positive. We're going to minus x from both sides. You get 2x and then add 4, and that's going to give you 18. To get the number terms to the right side, we're going to minus 4 from both sides of the equation. Notice I'm doing it once to each side. And you get 2x is equal to 14 divided by 2. Your last step is going to be multiply or division. Get rid of the coefficient of x, and that's going to be x equals 7. Now, on the last one on this page, this column, or row, I guess we would call it, notice there are two x's on the same side. Don't add or subtract to move those. We're just going to combine them together. So 4x subtract 2x is 2x. So you can always combine like terms on the same side. If you, however, want to get the letter terms on the same side and they're on opposite sides, this is when you've got to add or subtract that term to move it to the other. So we're going to subtract 8x to move it to the left side. And negative 6x minus 5 is equal to, bring down the 7. We're going to add 5 to both sides, and we're going to get negative 6x is equal to 12. Divide by negative 6. Again, to get rid of a coefficient, you multiply or divide. And x equals negative 2 for this problem. I'm going to go into a couple word problems, okay? And these are a little weird, and then we're going to go back to some of these steps and say, how do you deal with a couple more of these things, and what do you do if things turn a little weird? So here we go. Word problems first. We got a couple more steps today. Okay, we are selling candles to raise some money. And so the thing is that they tell us a couple of facts. They say it costs $100 to rent the booth, so that's an expense you have. And then the candles cost you $1 each to buy them. So those are some expenses you're doing to set up. And the thing is, our hope is we're trying to make some money. And so we're going to sell them. How we're going to make money is sell them for $5 each. Now, when you were a kid, you probably thought about like, well, if I want to make money, I'm just going to sell a bunch of candles. If I make $5 each, I'm going to literally take home $5 each. But you're like, no, actually, you have to pay back some of your loans in order to set up your shop. And so your costs, I'm going to put on one side of the equation, and I'm going to put your income on the other side. We're going to say, when do you start making money? How many candles do you have to sell? The costs you've already put into the business are equaled by how much you've gotten, taken in money for candles, and then after that, you're going to start making money. So the cost you've already used would be $100, and you buy candles at $1 each. So X equals the number of candles you bought. And you sell them for $5 each candle. And so the thing is, when you've sold enough candles at $5 each, you're going to say, oh, I paid back that $100 original fee, and then also the investment to buy the candle stock. And so after you've paid back your investment, you're going to start making money for every candle that you sell. You're going to make $4 for every candle after that. So let's see if we can figure out how many candles you have to sell so that you can start making $4 for every additional candle that you sell. Because again, you still have to pay for a dollar for reimbursing yourself for a candle, but it's just everyone is going to give you $4 income. So this would be 4x and divide by 4. I don't know why I put 100 and x on that. Okay, and so x is equal to 25 candles. So you tell yourself I would have to sell 25 candles and then I pay back my money. After that, you start making money. Okay, and the rate we already talked about. A dog, okay. I think I'm trying to be like, find the weight. And then also, the dog weighs 2 pounds less than 3 times a cat. So 3 cats minus 2, okay. Another way to talk about a dog equals 22 pounds more than what a cat is. So 22 plus a cat. Okay, so there's 2 ways that we're talking about what a dog can weigh. And so what we can do is say, well, I've got 2 ways to express this in terms of cats. We can actually say, well, then that means a dog weighs 3 minus C minus 2, or also a dog weighs 22 plus C. There's 2 ways to talk about how much a dog weighs. It's kind of an awkward way to speak, but there are 2 ways we can say, if you want to figure out how much a cat weighs, and then we can say, let's solve for C. So it's minus C from both sides. You get 2C minus 2 equals 22. If I add 2 to both sides, I'm going to get 2C is equal to 24, divide by 2, C is equal to 12. So a cat equals 12 pounds. Okay. And then it says a dog, and then we can use either one to find this. A dog weighs 22 more than a cat. Okay, so then you do 22 plus a cat, which is 12, so it'd be 34. Okay, so then how do we do the other one? If you look at the original directions, what you can do is you can tidy up each side individually. On the left side, you can't combine like terms. There's nothing alike. On the right side, we can distribute. We can't combine any like terms. But on the right side, you get 4x minus 10. On the left side, you get 7x plus 2. So if we want to solve this for x, we want to subtract or add to get all the x terms to one side. You get 3x plus 2 is equal to negative 10. Bring down the negative with the 10. So subtract 2 to get the number terms to the same side, constant terms. You get negative 12 divided by 3. You get x is equal to negative 4. Okay, over here, again, draw this vertical line, distribute on the left. You get 8x plus 4. On the right, you get 2x minus 26. To get the letter terms to one side, I'm going to minus 2x to get it to the same side. You get 6x plus 4 is equal to negative 26. Minus 4 from both sides to get the constants to the same side. Divide by 6, you get x equals negative 5. So distribute as you want to, and then anytime you want to move a term from one side to the other, add or subtract, do the opposite of the sign of that term. Okay, so let's solve this. If you got a fraction bar in it, 2 more sections. The way that you do this is you can multiply both sides by 2 because dividing by 2, the opposite is multiplying both sides by 2. It cancels out or distributes. We're going to cancel it out. You get 9x plus 6 minus 4x is equal to 16. A lot of kids forget to do it to both sides. These are on the same side. Do you see that? And so we are going to combine like terms on the side. 9x minus 4x is going to be 5x plus 6 is equal to 16. Minusing 6 from both sides, you get 5x is equal to 10 divided by 5, x equals 2. All right, so if you see just a fraction on one side, you can multiply both sides by that denominator and you get to cancel it out or distribute. I would pick cancel it out. On the right side, you're going to get 20x. To get all the terms one side, it doesn't really make sense to move it away from the right side because that's all there is. And so we're going to move the letter terms to the right side, constant, the variable term. So 16 is equal to 8x divided by 8. X is equal to 2. Okay, and the last one. You see a little fractions multiplied by a common denominator over 1, which would be 20. So if you times both of these by 20 over 1, you're going to get 40x over 5. You're going to get minus 60x over 4 equals 20 times 3.5 is going to be 70. And then what we're going to do then is we're going to reduce those fractions. 40 divided by 5 is 8x. 60 divided by 4 is going to be 15x equals 70. These together make negative 7x equals 70 divided by negative 7. And you can either multiply fractions like how you know to multiply the top, multiply the bottom, and then divide or reduce, or you can use your fraction key if you've got one. Okay, the next thing would be sometimes you solve a problem and it has no solution or infinitely many solutions. And so let's look at this. On the left side, there are no combining like terms. On the right side, there is no distributing, but there are some like terms. You get 5x plus 9. Now notice these are the same thing. 5x plus 9 is equal to 5x plus 9. And so if we try to move the letter terms to the same side by subtracting 5x, you get 9 equals 9, which was an identity. It means any value that you plug in both sides of the equations will make the equation true. And so if we're doing 18x minus 6 on the right, we get 18 minus x minus 5. If you minus 18x from both sides to get all the letters on one side, you get negative 5 equals negative 6. We interpret that to be that there's no solution. And a lot of times I try to show why. If you have x plus 5 equals x plus 1, and think about what could I plug into both sides of the equation where you add 5 to it and you add 1 to it and you get the same answer. Even if you try 0, 0 plus 5 is not the same as 0 plus 1. Nothing you plug in, you have to plug in the same number to both sides of the problem. There is no value that you could plug into both sides to make that equation true. So when you do that, that means nothing you try will ever work. Infinitely many solutions or identity means that anything you try on both sides will actually work. If I say x plus 2 equals x plus 2, you're like, well, whatever I put on the left and the right side, if I have to put the same number in, that will be a true statement. No matter whether I plug in for x, as long as I pick the same value on both sides, it's going to make a true statement. 7 equals 7. Okay, so last one. It should be the negative here. You get negative 14 minus 2x plus 7 equals negative 2x minus 7. Combine like terms. You get negative 2x minus 7 equals negative 2x minus 7. If you add 2x to the sides, negative 7 equals negative 7. This is an identity. All right. Well, thank you so much. I hope you have a great day.